everyone. We are Team Endurance and we are excited to share our idea cum innovation for the Smart India Hackathon 2025. Every year, disasters like floods, earthquakes, and landslides affect thousands of people in remote areas. The biggest challenge is that help often arrives too late, making the lives and keeping the health of the victims at risk. To solve this, we have proposed a revolutionary idea, multi-drone disaster response system. Our system continuously work to reach the people faster and to close the critical gap until the professional rescue team arrives, making the disaster relief faster, safer, and more effective.
Now let me explain our zero latency, two autonomous drone, search and rescue disaster relief system. First, we have a scout drone. It is like a VTOL drone, it's like this, and it is a VTOL drone so that it can take off and land vertically like a helicopter. It is a lightweight AI-powered unit which can continuously scan for the survivor in the disaster-affected region. As it is a VTOL drone, so it can glide over the disaster-affected region, search for the survivors continuously without frequent battery charging. Secondly, we have a quadcopter or hexacopter like heavy load crew, which we will be using for providing relief to the survivors. It is a heavy payload system which will be autonomously operating depending upon the inputs of the scout drone. So our innovation come idea lies in the parallel workflow which we are providing in search and rescue operation in disaster management. Currently, the disaster management system works on a linear operation, that is search, locate, come back and deliver. But by our innovative solution, we are providing a parallel workflow for search and rescue both at the same time. Our innovation provides zero latency workflow in the search and rescue, zero latency workflow in search and rescue, parallel workflow in search and rescue, instant help to the survivors, and similar.
Now let us explain about the survivor identification and geotagging. For this specific task, we will be using firstly an RGB camera which will provide FPV and shows the video frames at around 30 frames per second.
Secondly, we have an onboard flight computer, the NVIDIA Jetson N, which will be running an AI model called YOLO V8 or similar that we will fine tune according to our specific task of survivor identification in the disaster affected region. Lastly, after identifying the survivor in the disaster affected region, we need to geotag them using GPS and provide precise and accurate coordinates of latitude and longitude to the ground station as well as to the delivery drone, such that the help arrives to them precisely and accurately.
By using this workflow, we will aim to deliver an accurate, time-tested methodology for survivor identification and geotagging.
Now let us briefly explain our autonomous drone navigation tech stack. This system helps both the scout and delivery drone to move safely and detect and avoid obstacles, reach their targets automatically without any human intervention.
The brain of our system is autopilot, which is controlled by Pixoc flight controller and onboard Jetson Nano computer. The drone uses sensor fusion, which combines both the GPS and the IMU depth camera data to know the exact location and the surroundings. The vital component of our project is ROS, which is Robot Operating System. It manages all the high-level data for autonomous navigation. Or as the drone flies, it maps the 3D map and of the environment using the depth camera to detect and eliminate the obstacle, and it uses autopilot.
For the fail safe case like GPS loss, low battery, signal error, the drone switches to RTS algorithm, which is returned to home without any harm.
Hi, I am Jamshed Khan, a final year BTech student and a member of design team. We are designing a two drone using Autodesk. First is Scout drone, which is going to be configured as the VTOL drone. The second is delivery drone, which is going to be considered the quadcopter.
The Scout VTOL drone features a 1200 millimeter wingspan and 700 millimeter length with a lightweight PLA structure reinforced with carbon fiber. This Scout drone weighs between 1.5 to 1.8 kilograms and it uses four 1700 kV motors for vertical lift and 1400 kV push-up motor for forward flight. The Scout drone, powered by 30 amps ESCs and a power distribution board, this design achieves a range of 60 to 70 kilometers.
The quadcopter is made up of custom 3D printed frame with a carbon fiber rod with a diagonal span of 50 centimeters. It consists of 4 motors, 2 rotating in clockwise direction, the other 2 is rotating in anti-clockwise direction, making it more efficient for precise delivery.
In disaster, every second counts. Traditional single drone solution follows linear workflow model which wastes precious minutes, which is search, locate, come back to base station and deliver the help. Our innovative solution is targeting that specific delay.
One drone autonomously searches the survivors and while the other delivers the essential supplies. We provide parallel workflow with zero latency for search and rescue operations.
Our solution entirely built with mature open source technology and readily components available across India that makes our project 100% feasible.
The future version of our solution may scale up in a solution which may have one scout drone and multiple delivery drones to furthermore increase the efficiency of the solution.
At the end, it isn't a concept. It is a scalable and deployable solution. This is a Scout Delivery paradigm, and we are the team Endurance. Thank you.